Welcome back guys. So today I'm going to start with HashMap, and this is one of the most important collection class which we often use, right? So it's not only HashMap, the HashMap, linked HashMap and tree map. Similar to set what we have studied, hash set, linked hash set and tree set. If you look at here, the concept remains same, okay? Only the way it works, the method you have, it is the different, but the way it works internally it's almost same, because hashset also internally uses hashmap, and hashmap, the methods of the hashmap is quite different than the hashset, okay? But this is the most widely used class in the collections framework. So first we'll try to understand the internal implementations part, and then we'll go ahead with the hashmap. So if you look at here, uh, that's how you create the object of HashMap, right? So you know that map is the interface, right? So if you look at here, this is the interface. So this map is the interface. This is the interface. So you are creating the reference of interface. And here in case of map, in angle bracket, it takes two objects. One is the key and one is the value for the key, right? If I have to give one real-time example, let's say what happens is, you are making the object of a person and you have a requirement for every person you need to keep an address. So what you can do, you can create person as the key and address is the value, okay? Again, one more, for person P1 address is address 1, for person P2 address is equal to address 2. That's how you can do that. And when you have an interface, there should be a class which should have the implementations for the interface. So map is the interface, okay, and the HashMap is the class. So whatever you are seeing there, this HashMap is the class which has the all the implementations of the map interface hash, right? So that's how we create the object of HashMap. Anyways, I will cover in the details. I will also show you what is the internal implementations, how it works, what is the hierarchy, but here we will go with first understanding of what happens internally when you store the data in the HashMap, okay? So map has a method called put method. Till now in the array list, linked list, in the set classes, you have seen that there was a method called add method, okay? But here, to keep the data in the map, you have a put method. So remember this, here you have a put method, and put method will take two arguments. If you look at here, the argument is key and value. So your key is a string and value is equal to 10. Again you are putting 4 records in the map, right? So there is a 4 argument, and every argument you will have a key and value, right? And this put method will help you to add the data in the map, right? First thing. Second thing, map will not maintain the insertion order. The way you will insert and the way you will fetch the data from the map, it will not be the same, but we'll go all these things later. We'll try to understand how it works internally, how it will store the data internally. Now if you look at here down, map has a method called entry set. You can look at here, map has a method called entry set. So basically the entry set will give you the set of the entry, right? And you know that set is unique, and anyways the entry will be unique. So when we say entry set, so whenever you keep the record in the map.put, basically you are keeping one entry to the map. Again when you do map.put one more, you are keeping one more entry to the map, right? So when you are keeping this record to the map as a form of entry, there is a method called, on this reference map, you can see that on this map reference you are calling dot entry set. So when you will call the entry set, this is your reference through which you are trying to access. So this is your reference of the entry set. I am just creating one reference variable, and if you look at the return type of this entry set is nothing but set of, in angle bracket, entry, okay? Set of entry. Basically you will get a set, and in angle bracket the type of object. So basically in angle bracket the object is entry, right? So object is an entry, and what is the type of entry? In angle bracket a string comma integer, because that's what you have stored, a string and integer, right? So you can see that entry set will give you the set of the entry, So in set angle bracket you have an entry, and if you look at this entry, whatever you are seeing that here, this is the entry type, right? Whatever you can see that in this curly braces, which is nothing but entry type. So whatever you are seeing that, so from here to here, this is the entry type, a string comma integer. And whatever you are seeing that this final angle bracket, so this is complete set of entry. So this is your set of entry. Okay, so once you have a set of entry, you can run a for each loop. Okay, and again when you are running a for each loop, one by one from this entry set you will get the data, you will get an entry one by one, and again the what it would be the return type of this entry. The return type of the entry is going to be entry of a string comma integer, entry of a string comma integer, because what is the type here? Type, see what data you are getting by the entry set, you are getting that entry comma string comma integer. So here also you will get entry angle bracket string comma integer, right? Everything I will show you through a clips. Try to understand here because I have to show the internal implementations here. Now when you have an entry set, so basically when you keep an entry here, what you are keeping in the form of entry, you are keeping that key and value. So this entry, whatever entry you have, it has a method called get key. When you do get key, basically it will give you the key object. Whatever you have stored as a key object, you will get a key object, which is nothing but a string. And you know that when you have a key object, you can make a hash code call. So on this every object, you know that you will have hash code available, so you can make a hash code call, right? So you are making a hash code call. This is the hash code call is the method. This will see that through Eclipse also. Okay, so quickly I will show you this. So if you look at here, this is your set. Okay, and you are calling the hash code here. You are calling the hash code here. Here I am printing the key, and then I am doing that modulus of 15. Modulus of 15, why I am doing that, I will show you, right? So you can see that here also you will have the same thing. And in fact, you don't need to remember this. When you just delete that, when you just place mouse over here, click on create local variable, automatic you will get set of entry. So this is the one part, and this is the one part. You can see that now you can correlate. This is one part. So this is one part. This is nothing but entry of a string integer, and this everything comes in the set. Okay, which is nothing but set of entry. So now again when you run a for each loop, here everything comes under entry, right? Because when you run a for each loop, one by one, what you will get? You will get entry only, right? So one by one you will get an entry. Now what you have entry, this on this entry reference you have a method called get key, and get key is nothing but object. So you can make a call of hash code, and then for the same hash code you are doing that modulus of 15. Three things you try to understand here. Now come back to the PDF. So what happens when you are adding the record, you can see that for test 1 this is the hash code, and what is this 0? So what happens when you do hash code modulus 15 basically? So when you try to do hash code modulus 15, let me write that when you do hash code modulus 15, you will get index. Index is equal to hash code modulus 15. So that is the reason you are getting that 0 here. Whatever 0 you are getting that. Again when you have added, so actually when you run a for each loop and when you print, you can see that at second entry was test 2, but when you are running this, you are getting that test 5 because it will not maintain the insertion order. The way you insert in the map, the same way you cannot get it. So for test 5, this is the hash code and index is equal to 4. So again for this hash code, when you do a modulus of 15, you will got a 4. For test 3, this is the hash code, and when you do hash code of this modulus, you got a 2. 2 is nothing but index. Again for test 2, when you did a modulus of this hash code by 15, you got a 1. So you know that what happens when you try to store the data in the HashMap. Okay, this is the internal implementations of the HashMap. So what happens basically when you create the object of HashMap, by default size of 16 one bucket will get created. So first what will happen, one bucket will get created of size 16. So whatever bucket you are seeing, that only the bucket will get created of size 16, right? So index start from the 0, so it will be 0 to 15. You can see that 0 to 15. Now what happens here is, once this bucket is created, how data insertions happens? When you make a put call, what happens? Whenever you do a put call, okay, internally hash will get generated for this key. So for the test one hash will get generated, which is nothing but I'm just calling a hash code. So for this test one hash code will get generated, and then if you look at here, you have a bucket of size 0 to 15. So when you have a size bucket 0 to 15, actually your data need to be stored into the 0 to 15. So wherever you want all your hash code to be stored somewhere 0 to 15, any number, so any number, when you do modulus of 15, you will always get index between 0 to 15. Okay, the index will never go beyond 0 to 15 because you are doing that the modulus. So basically what happens here is, when you did modulus of this, you will got a 0 index. So on this 0 index, this test 1 will get added. So what happens here, on this 0 index, one node will get created. Okay, one node will get created, and node will have a key and value. Okay, node will have a key and value. So basically what happens in real time, one node will get created like this, right? And node, what you will have, node you will have a key. So node will have lot of things actually. Your node will have your hash code. So node you will have hash code, then node will have key, then node you will have value, and node you will have next pointer. So this many things your node has. Your node has hash code, okay, your node has a key, okay, so your node has a hash code, your node has a key, your node has a value, and node has a next pointer. That's how one node will get created. So basically what happens, on 0 index, this test 1 will get created. Okay, test 1 is this key. This key will get created, and then for this key, whatever value you have, let's say you can write it here also, the value 10 will get added here. Okay, and this is the next. So for now, next is pointing to null. For now, all the next is pointing to the null. Here I have same hash code I have copied here. So just I wanted to show you for this test one, what is the address of the node. So for this test one node got added at the 0 index. The address of this node is nothing but this. This is the address of the node. Okay, 80698815. This is the address of the node, right? This is the address of the node. Now when again what happened, when you try to add test 2, okay, so for test 2, what is the modulus of 15? 1. When you divide this hash code by modulus 15, you will get a 1. So on 1, test 2 will get added. So you can look at here, at 1 index, one node got created, test 2, and this test 2, if you look at what is the index, so where it got added, at index 1, and here the hash code is 8816. So if you look at here 8816, right, one node got added. So you can see that one node got added here. So for this test 2, this is the address of the node. So for this node, test 2 node, this is the address. And again, what is for test 2, what is the value? It is 10. So value I am keeping it common, no problem. Value you can keep duplicate, right? So this is 10, right? Again, if you look at, we are adding the test 3. So for test 3, what is the hash code? So this hash code we are getting from here, okay? Hash code you will get this 8817. When you do modulus of 15, you will get an index 2. So on second index, you will have test 3, and this index is equal to 8817. So this is for your test 3, right? So this is for your, so whatever test 3 you have here the address of this node. 8817. I have written here because I didn't have this much space here, so I have just written here. I'm just trying to explain you, and why I have given this arrow mark, so that you can understand for this node this is the address, for second node this is the address, right? So if you go there for the second node, which is nothing but test2, if you'll see this node, okay, this is the address. Okay, you can correlate now. Now for test 1, this guy, sorry, so for test 1, actually if you'll go, so I'll make the same color. For this guy, this is the node. Okay, clear? Now for the test 5, what we did, we added test 5. For test 5 here, if you look at, index is equal to 4 and 8819. So for test 5, index is equal to 4, this is the one, which is nothing but 8819. So if you look at here, this is for test 5, this is for test 5, and this is your test 5, right? You can see that these are the address of the node. So these are nothing but whatever I have written here is nothing but address of node. Okay, address of node, whatever I have written here, these are nothing but address of the node, okay, which I have kept it here. Now what happens, assume that in map you are going to store one more record, and what happens again, for the same for that record you will get index is equal to 1. For the second record you will get index is equal to 1. So what happens, first it will check for the hash code. If the hash code is not same, if the hash code is same, assume that if the hash code is same, so on second index, what is the hash code? 8816. So again you are trying to store one more data, which is, let's say, test 20. You will get the same hash code. Then what it will do, it will compare the object. Okay, if the hash code is same, then it will compare the data also. Depends, like if you are overriding the equals method, it will compare the data also, or it will compare the reference. If both are same, then it will override. Let's say if hash code itself is not same, assume that you got the same index because you are doing that modulus of 15, right? So whatever index you are getting, that 0, 4, 2 and 1, because you are doing that modulus of 15. When you don't do, so let's say how you are getting this index, because you are doing that modulus of 15. So let's say when you have done modulus of 15, what happens, you got the index 1, but the hash code was not same, which means it is a different object. When the hash code is not same, one more node will get added here. One more node will get added here, and your first node will point to the second node. Your first node will point to the second node. In other node, what is happening is, see, if you look at this, all nodes, whatever nodes you are seeing, that basically it will all point to null. Okay, this guy will also point to null, this guy will also point to null, and now this guy will point to null, and this guy will also point to null. So always the node.next will point to null when there is no node associated. But here now what happens, now test2, in beginning it was pointing to null. In beginning it was pointing to null. The moment one more record came, one more data came to the same index and the hash code was different, one more node will get created, and your node test2, now it will point to this node, right, latest node, right? And let's say this record is nothing but test 20. Assume that this is nothing but test 20, right? So you got the different hash code, but the index was same. So that's how whenever you will get a collision, which means if the two object has the same index, that is the case of collision, what will happen, the node will get added. So node will be added, right? This how what happens when you do a put method. That's how internally it works. Now what about the get method? When somebody will do a get, because you know that in the map there is a method called get method. So like put method, similarly you have a method called get method to get the record. So map dot get, I'll cover this topic here itself, so that when I will start again, I don't have to cover. So when I will do a get, You know internally what happens when you perform a get operations? Same thing will happen. For get also, first for this key, for this, which is nothing but object, right? So you know that in map or any collections classes, whatever you store, you always store in the form of object. It will not take primitive data type. Okay, that is the thumb rule. Even though when you add integer data internally, it will do integer dot value of. If you add the double data internally, it will do double dot value of, and you know that dot value of method will always return object, but when you do integer dot parse int, that will return primitive data type. When you do double dot parse double, you will get primitive data type, but when you do double dot value of, you will get object, which everything I have already explained in my previous video. So when you do get, what happens? So whatever I explained till now, it's all about put call. Now what about the get? So for get also same thing will happen. For test one, first what happens is the hash code will get generated. Always for the test one, hash code will get generated. So you will get a hash code. Let's say for the test one, this is your hash code. Okay, this is the hash code for test one. So this guy is the hash code for, let's say, test one. This guy is the hash code for test one. So when the hash code will get generated, what it will do for this hash code, particular hash code, you are seeing that it will do a modulus of 15. So for this hash code, what will happen is it will be a modulus of 15. When you do modulus of 15, what you will get? You will get a 0, right? So then when the moment you will get a 0, then what it will do, your this Java runtime will go and it will check on the 0 index. On the 0 index, on this the index, it will fetch the node. First it will check on the 0 index there is any object associated, any node associated. Yes, there is a node. Then for this node, it will get the address of the node. So for this node, the address is nothing but 8815, which will compare for the address of test one, which will compare the address of test one. So it will compare the address of test one. If both matches, right? If both matches, it will return this node. If both matches, it will return that. Assume that this case, what happens? You are looking for test 20. Let's say you are looking for test 20. Okay, you are doing that map.get test 20. So here for test 20, first what it will do, for test 20, it will generate, for this guy, it will generate the hash code. So when you generate the hash code, and then it will do a modulus of 15. When you do a modulus of 15, let's say, for example, you got the index is equal to 1. When you got the index is equal to 1, it will check, your Java runtime will check whether this 1 has any node associated. Yes, it has a node. Okay, it will get the address of the node. For this test 2, if you look at, this is the address. This is the address 8816. So you got the address. Now what it will do, it will compare the address. It will compare the address for which it is generated the index. It will compare, it will not match. Then it will check whether this node is associated with some other node. Yes, this node is associated with one more node, which is test 20. So it will get this node, and then for this node, it will get the address. So let's say this has a address is equal to 500, for understanding 500. Then it will get the address is equal to 500. When this is 500, it will compare, okay, hash code is matching 500. Then it will return this node. It will return this node. So that's how get works. That's how the get will work, right? Clear? You got the internal implementations, how when you do put and how when you do get, how HashMap works internally. So with this, guys, I will close the video. From next video onwards, I will start with the coding part. Thank you, guys. Thank you for watching this.